Hi guys, welcome back to Mathematics for Engineering 3. Today, we are going to be talking about the boundary valued problems, okay, which is the sixth section. Okay, to solve the boundary value problems. In the previous videos, in the previous video we looked at how to solve the initial value problem, right? The difference between the initial valued problems and the boundary valued problem is that here the condition here is it's not y0. It's not always y0. Okay, because if it's the initial value problem, you need to have y0 equals something and y prime 0 equals something, right? But if it's a boundary valued problems, this value they might not be 0. It can be 0 here, or it can be some other values as well. Okay, so whenever one of these values are not 0, we call the problem the boundary valued problems. Okay, and in order to solve this problem, first we would apply the Laplace transform through the equation to the whole equation. Okay, and it's the same as what we did before for the initial valued problem, right? And secondly, because we don't know the value of y0 or y prime 0, we might not know one of them, or we might not know both of them. So we will let there be a, b, c, or d, let there be constants basically. And after that we solve for ys. Okay, it's the same step, right? We solve for yf's, but it will be in terms of a, b, and c. Okay, it will be in terms of constants. Okay, so this is a new step. Okay, which is to let the conditions that we don't know be a, b, c, d, blah blah blah. Okay, and then we solve for ys, the big ys, in terms of the constant. After that, we apply the inverse Laplace transform. Okay, so this step, they are exactly the same as the previous problem, right? The initial value problem. And the fifth step, that is the additional step. We need to use the boundary conditions, which is these two conditions, to solve for the constants that we let them be a, b, c, or d. Okay, things will become clearer when you look at the examples. Okay, so let's go and look at the examples. Here, solve these boundary valued problems. Guys, I'm sorry, we need to change here. It's not initial, it's boundary value problems. Okay, so first we would apply the Laplace transform to the whole equation, plus 2 Laplace transform of y prime plus Laplace transform of y equals Laplace transform of t. And Laplace transform of y double prime, that is s squared ys plus s, and then y0, and then plus y prime 0. Okay, that is the Laplace transform of y double prime. And then plus 2 Laplace transform of y prime, that would be s, the big ys, plus y0. Okay, and after that it is plus Laplace transform of y, which is ys, and that equals Laplace transform of t. And guys, y0 is minus 3. Okay, so we know y0 is minus 3. But here, we don't actually know y prime 0. Okay, unlike in the previous section, in the initial value problems, we know y prime 0. So there's no problem about that, right? So here, we don't know y prime 0. So in that case, we would let y prime 0 be a. Okay, so we can write this equation down like s squared ys minus 3s plus a plus 2 s ys minus 3 and then plus ys equals Laplace transform of t, that is one fact divided by s squared. Okay, pretty simple, isn't it? Okay, and then I just group the ys together, so I have ys squared plus 2s plus 1 ys, and then I push the rest to the right hand side, so I get 1 over s squared. So I push this guy to the right hand side, I get plus 3s minus a, and then I get plus 6, right? Oh, sorry guys, here the formula is minus, not plus, my bad. It's minus here, not plus, right? If you go back and look at the formulas, this one, this formula, they are all minus, right? Right, but no worry, you have this formula in the exam. Okay, so here I'll change that to minus, which means that this would be plus and this would be minus a, and this would be plus, and that means we have 1 over s squared minus 3s plus a and then minus 6, right? Right, and then we have that ys. Okay, let me first this is s squared, this is s plus 1 squared, right? S plus 1 squared ys equals 1 over s squared minus 3s plus a minus 6. So which means that ys is 1 over s plus 1 squared s squared minus 3s divided by s plus 1 squared plus a minus 6 divided by s plus 1 squared. Okay, and that is 1 over s plus 1 squared s squared, and then minus here I put s squared here, I put s squared here, s squared here, s squared here, which means that I have 3x cubed plus a minus 6 s squared divided by s squared, s plus 1 squared, s squared, and s plus 1 squared, s squared. Okay, which means that this is 1 minus 3s cubed plus a minus 6 s squared divided by s plus 1 s plus 1 squared s squared. Okay, and these guys you can use partial fraction. Okay, oh sorry, not partial, you can use partial fractions to split this guy in terms of, I won't use a because a has been taken, right? So I will use b divided by s plus c divided by s squared plus d divided by s plus 1 plus e divided by s plus 1 squared. Okay, and you need to somehow uh, find the value of b, c, d, and e. Okay. Okay, so I'm not gonna show that. You can try doing that yourself, but I'll give you the result. And here it would be 1 over s squared minus 2 over s minus 1 over s plus 1 plus a minus 2 divided by s plus 1 squared. Okay, guys, don't forget, right now a is taken. Okay, we can compute b, c, d, and e in terms of a. So we think of a as a number. Okay, we think of it as a number. Cool, cool. Which means that we do need to find yt. We do need to find yt. Oops. And this is the big ys. So if you want to find yt, you just need to apply inverse Laplace transform to this guy. Okay, and to do that is now very simple, right? The first one would be, what is it? What is the Laplace transform of the first one? That is just t, right? Because the lt is 1 over s squared, right? So the next one would be 2, right? And the next one would be e to the minus t, and then you get inverse Laplace transform of 1 over s. Don't forget, guys, here is s minus 1. Okay, so we can pull that out. You get e to the minus at, sorry, e to the at. Okay, and then you have plus a minus 2, and then you have e to the minus t, inverse Laplace transform of 1 over s squared. So you get t minus 2 minus e to the minus t. This inverse Laplace transform is just 1, plus a minus 2 and e to the minus t, inverse Laplace transform of 1 over s squared, that is just t. Okay, okay, so we have yt as t minus 2 minus e to the minus t plus a minus 2 e to the minus tt. But guys, that is the fourth step. We apply the inverse Laplace transform to get little ft. In this case is yt. Okay, but right now we still have the big A there, right? So we need to get rid of A. So we use the fifth step, which is to use the boundary conditions to solve for A and B and C and blah blah blah. In this case, we only have the big A. So because, oh guys, sorry, there's a typo. Here it's just y, okay? y1, that is y1 equals minus 1. Okay, not y prime, sorry, just y1. y1 equals minus 1. Okay, so because y1 equals minus 1, that's a typo, sorry, it's just y1. y1 equals minus 1. So we get minus 1 equal 1 minus 2 minus e to the minus 1 plus a minus 2 e to the minus 1, right? And here, these cancel out. So we have that it is 0 equals minus 1 over e plus a minus 2 over e, which means that we have 0 is minus 1 plus a minus 2 over e, which means that minus 1 plus a minus 2 is 0. So a is 3. Okay, so if a is 3, it means that our solution is yt equals t minus 2 minus e to the minus t plus 1 e to the minus t. Just substitute this a by 1, a by 3, and that's it. Okay, so guys, to recap here, first we apply the Laplace transform, okay, to the whole equation. So here I just use the Laplace transform of the derivatives. Okay, and then guys, we do know this part, right, which is minus 3, but we do not know this part, so I let this part be a. Okay, and I leave it like that. So I get ys in terms of a. We have a there. Okay, and then we can get yt by the inverse Laplace transform of the ys. Okay, and then here is the yt, but we do have a here, but we haven't used this condition yet. So we have the condition that y1 is minus 1. So I put 1 in t. Okay, I put 1 in t. And then y1 is minus 1. So I can get a equals 3. And then I substitute this a with 3. And I obtain the solution. Okay, and it's quite simple. Okay, but the hard part is to do the inverse Laplace transform, this inverse Laplace transform, okay, which involves changing the form of ys. Okay, okay, I hope that in the exam it won't be this hard. Okay, I hope it's gonna be easier. Okay, yet that you don't need to do lots of partial fractions and things. Okay, I hope it's gonna be a lot easier. I hope. Okay, okay, cool. uh Next example. Next example. Find the solution of the uh again guys, sorry, boundary value problem. Boundary value problem. Y double prime plus y equals 2t. Y of pi over 4 is half pi, and y prime of y over 4 is 2 minus square root 2. Okay, okay, and first we just need to apply the Laplace transform to the whole equation. Okay, and that means we have what is it? What is Laplace transform of y double prime? We did that quite a couple of times, right? So we get s squared ys plus s y0 plus y prime 0. Okay, that is the first thing. Okay, if you want, you can do it a little slower by doing it like that, like what we did before. Laplace transform of y double prime is this guy. Okay, and that is s squared ys. Y0, what is y0, guys? We don't know y0. We only know y pi over 4 and y prime pi over 4. So we don't actually know y0, right? So we need to let y0 be a. So that is going to be SA. And then again, we don't know y prime 0 as well. So we let y prime 0 be b. Okay. And then we have that will be plus b. Okay. So we have two constants in this problem, in this example. And next, Laplace transform y, that is just ys, and Laplace transform of 2t, that is 2, Laplace transform of t, that is 1 over s squared. Okay, and then we plug in all the things back into this equation. Okay, so we have s squared ys plus sa plus b plus ys equals 2 over s squared. So we have here s squared plus 1 ys, right? S squared plus 1 ys equals 2 divided by s squared minus sa minus b, and we have ys in terms of a and b. See, it's 2 over s squared plus 1 minus sa divided by s squared plus 1 minus b divided by s squared plus 1. Okay, and I think this a little easier than the previous one, right? This one we just need to change this. We just need to apply the partial fraction to this term, which is 2 over s squared and s squared plus 1, right? We just need to change to apply the partial fraction techniques to this term. Okay, and if you know how to do it, for this one, it is actually, you can do, okay, I'll show this one to you. Okay, so I'll use little a, s plus little b, s squared plus little c, s squared plus 1, or little c, s plus d. Okay. Okay, that's partial fraction. I hope you know how to do it. So 2 here is as plus b, oh sorry, as s squared plus 1 plus b s squared plus 1 plus cs plus d s squared. Okay, I multiply the whole equation by s squared plus 1. Okay, and first I let s be 0. So if I let s be 0, this guy is going to be 0, this guy is going to be 0. It means that 2 equals b times 1, which means that b is 2. Okay, right now I know that b is 2. So I change this to 2. Okay, okay. And after that, if I want to know some other terms, I just need to first write this in terms of 2 equals as cubed plus as plus 2s squared plus 2 plus cs cubed plus ds squared. Okay, and we have that a plus c s cubed, and then we have 2 plus d s squared, and we have as, and then we have plus 2. Okay, but guys, we want to do the undetermined coefficients, right? So here, if you know, it's actually plus 0s plus 0s squared plus 0s cubed, right? Which means that a plus c is 0. Uh, 2 plus d is 0 as well, and a is 0, and here 2 equals 2. Okay, so if a is 0, it means that c is also 0. Okay, and d is minus 2. Okay, that is the partial fraction. So here right now we know a b c d, right? Which means that we know that 2 over s squared times s squared plus 1 is a, that's 0. B is 2, so we have 2 over s squared plus c is 0, and d is minus 2. So we get minus 2 divided by s squared plus 1. Okay, this is the whole thing. This whole thing is the partial fractions. Okay, okay. So I can substitute this, which is this guy, and it can be written in terms of this. Okay, so if I get to the new page, I would have that ys is actually 2 over s squared minus 2 over s squared plus 1, right? 2 over s squared plus 1, and then minus as divided by s squared plus 1. Oh, guys, again, I'm so sorry. I made the same mistakes again. Guys, don't make the mistakes that I made, okay? Here again, guys. Here again. It is negative, not positive. Sorry. Right? Here again, guys, it's negative, not positive. You might already realize it while you were watching, right? But you didn't have the way to tell me, right? So it's negative, it's not positive. Okay, which means that here is going to be minus, not plus. Okay, okay, which means that there is going to be minus, not plus, right? Right, so here we would have plus and plus, plus and plus. So here that will be plus and plus, plus and plus. Okay, my bad. Okay, then we can find yt, which is the, let me write a little better, yt, which is the inverse Laplace transform of ys, and that would be inverse Laplace transform of 2 over s squared. What is it? Okay, I'm gonna write it down right now, okay, because it's quite simple. So it's 2t, right, minus here it's gonna be 2 times what is it, here it's gonna be psi t, and then plus a times cos t plus b psi t. Okay, and that can be simplified to 2t, and then plus b minus 2 psi t plus a cos t, and that's it. Okay, but guys, again, we still have a and b, so we do need to use these boundary conditions. Okay, to get rid of a and b. Okay, so the boundary condition says that y of pi over 4 is half pi, and y prime of pi over 4 is 2 minus square root 2. Okay, so I will put pi over 4 in here in the t first, so I get half pi equals 2 times pi over 4 plus b minus 2 sine pi over 4, that is square root 2 divided by 2, right, plus a, and cos pi over 4, that's square root 2 divided by 2 as well. So I here that is over 2 as well, so I multiply 2 to the whole equation, so I get pi equals pi plus b minus 2 square root 2 plus a square root 2, and these cancel out, right, so we have 0 equals b minus 2 square root 2 plus a square root 2, and then I divide the whole equation by square root 2, so I get that is 0 equals b minus 2 plus a. So I have one equation, which is a plus b is 2. Okay, or we can say that a plus b is 2. And then we need to use the other condition, right? So first we need to differentiate. We have y prime t is 2 plus b minus 2, the derivative of psi is cos t, and then we get minus a psi t, because the derivative of cos is minus psi. And then again, we put pi over 4 in t, so we get 2 minus square root 2 equal to plus b minus 2 cos of pi over 4, that's square root 2 divided by 2, minus a square root 2 divided by 2. And these two cancel out, right? And then I divide the whole equation by square root 2. So I get minus 1 equals b minus 2 over 2 minus a over 2. And then I multiply the whole equation by 2. So I get minus 2 equal b minus 2 minus a, which means that we have b minus a equals 0, because this minus 2 cancel out. Okay, and because a plus b is 2 and a minus b is 0, I take the sum of this and this. Okay, I take the sum of this and that, so I have that 2b is 2, which means that b is actually 1. So if b is 1, a is 1 as well. Okay, so we have that b and a are 1, which means that our solution is yt equals 2t, and then 1 minus 2, that would be minus 1 psi t plus cos t, and that is the solution. Okay, and guys, that's it for the boundary value problems. Okay, it's pretty much the same as initial value problem, right? But it's a little harder because you don't know the initial conditions. You don't know y zero, you don't know y prime zero. Okay, but if you don't know them, no problem. You let them be a, b, c, blah blah blah, right? You let them be a and b. After that, you solve for ys in terms of a and b, right? After that, you apply the inverse Laplace transform, so you get yt. Then you use the the boundary conditions to get the constants a and b, and then you obtain the solution. Okay, for the last question, if you notice, I show you how to do the partial fractions. Okay, but in the previous questions I didn't show you. I just gave you the results because I assume that you all can do partial fractions. Okay, but if you can't do partial fractions, we will try to do that in the on-site class. Okay. Okay, but I hope you can try to practice the partial fractions. It's from calculus 1, right? When you do need to integrate like 1 over s minus 1 times s minus 2, right? You need to use a partial fraction to split s minus 1 times s minus 2 to two fractions, right? And then you do integration, and that's the same technique. Okay, so I hope you still remember how to do the partial fractions. Okay, guys, see you in the next video. And the next video will be our last video of the final one. Okay, and you should right now be prepared for the final one. Okay, especially those who didn't perform well in the midterm exam. Okay, so see you again next time. Bye bye.